Hello everyone, welcome to EnggClasses YouTube channel for a video lecture series in digital signal processing. In this video lecture, we shall consider the concept of bilinear transformation design procedure in designing of IIR filters. So what is the design procedure? The bilinear transformation, briefly known as BLT, design procedure can be summarized as below. Basically, there are three steps and I need to follow those three steps to design a digital IIR filter. Step number one, what is that? Given the digital filter frequency specifications, pre-warp the digital frequency specifications to the analog frequency specifications. What does that mean? In the numerical, it is asked to design an IIR digital filter, but the same digital frequency specifications will be given, but I'm unable to design digital filter in the first go. So what I have to do, I have to design first analog filter. To design those analog filter, I have to convert the given digital frequency specifications to the analog domain. So that is called pre-warping. I need to pre-warp the digital frequency specifications to the analog frequency specifications. So how can I do that? I have a formula for that. Omega A is equal to 2 by capital T tan of omega d into t divided by 2. If I do that, I'm going to get analog frequency specifications. So continuing further, we'll move on to the step number 2. Perform the prototype transformation using the low pass prototype HP of S. What does this mean? So now I have the prototype low pass filter. It will be asked in the numerical design a low pass filter, high pass filter, band pass filter or band stop filter. Whatever I have now is the prototype low pass filter. Now I need to convert that prototype to the given low pass filter. So how is that possible? HL of S is equal to HP of S. What I have to do in the equation? In the equation, I need to replace every S with S divided by omega A so that the prototype filter gets converted into the low pass with the given specifications. If it is asked to design a high pass filter, so what I initially designed is a prototype low pass filter. So now I need to convert that into high pass filter. H of S is equal to HP of S. So what I have to do, I have to replace every S with omega A divided by ES. Similarly, if I want to design a band pass filter from the low pass prototype filter, what should I do? I need to replace every S with S square plus omega naught square divided by S into W. Is that fine? If I want to design a band stop filter, then in the equation of low pass prototype filter, I need to replace every S with S into W divided by S square plus omega naught square. So this is step number 2, very important. After the end of step 2, I have designed an analog filter. If it is asked low pass, I would have designed an analog low pass filter or analog high pass filter or analog band pass filter or analog band stop filter. But what usually I'm concerned with a digital IIR filter. So how do I do that? That can be taken care in step number 3. So what is that? Substitute the BLT, means bilinear transformation, to obtain the digital filter. So now in step number 3, I need to convert analog filter into its equivalent digital filter. Is that fine? So what is the way? One of the ways is bilinear transformation. Like this, there are other methods also which I can make use to convert an analog filter into digital filter. So what should I have to do in the equation? In the equation, h of s, I'm going to get that into h of z. This is digital filter. H of s is in analog domain, and I'm converting that h of s into its equivalent digital domain. What should I do in the equation of h of s? I need to substitute for yes, which is equal to 2 by t into bracket 1 minus z inverse divided by 1 plus z inverse. I need to replace every z with this, every s with this equation, so that I'm moving on from analog domain to the digital domain. So I said this is the bilinear transformation equation. So if I do that, I'm going to convert the given analog filter with the required specification to its digital filter with its required specification. Now the task is done. I have explained this video in brief. I hope you people have understood. If still there are any doubts, please let me know them on to the comment section, and I'm happy to answer those doubts. Thank you so much for watching.